Hello everybody, getting ready to do lesson 10.1 part 2, pre-calculus math today classwork. And for today's classwork lesson, you will have 8 points that will go into your notebook and 42 points that will go onto your classwork sheet. Name, date, period, students, due date for my onliners and homeschoolers. Today's bell work, students, teachers, solve the quadratic equation by completing the square for these two. Give your students about 5-6 minutes. Teachers, see you in 5. Okay, welcome back everybody for today's solutions to today's bell work. For this one here, we divide our 5 here by 2, square it, add it to both sides. Now we have a perfect square. Move this over here. Take the square root of both sides. Now we have x minus 5 over 2 equals plus or minus radical 5 over 2. Move our 5 halves over. So now we have x equals 5 over 2 plus or minus radical 5 over 2 for number 97. Number 98 here. Divide our 3 here by 2 and square it to both sides. Add that to both sides. 9 over 4, 9 over 4. After we move our 1 over here, then now we can take the square root of x plus 3 over 2, quantity squared. We have x plus 3 over 2 equals plus or minus radical 13 over 2. We move our 3 halves over, then we have x equals negative 3 over 2 plus or minus radical 13 over 2. Okay, so moving on to our part 2 here, the equation of a sphere. So a sphere with center h, k, and j and radius r is defined as a set of all points x, y, and z such that the distance between x, y, and z is out here, and h, k, and j is r. So here's r. As shown, using the distance formula, this condition can be written as x minus h quantity squared plus y minus k quantity squared plus z minus j quantity squared, and then you take the radical square root of that, and that'll give you your distance of r. By squaring each side of this equation, you obtain the standard equation of a sphere. Okay, so the standard equation of a sphere with center at h, k, and j and radius r is given by x minus h quantity squared plus y minus k quantity squared plus z minus j quantity squared equals r squared. Notice the similarity of this formula to the equation of a circle in the plane. X minus h quantity squared plus y minus k quantity squared plus z minus j quantity squared equals r squared. This is the equation of a sphere in space. And then x minus h quantity squared plus y minus k quantity squared equals r squared. Remember, this is the equation of a circle in the plane. So there are similarities here. As is true with the equation of a circle, the equation of a sphere is simplified when the center lies at the origin. In this case, the equation is x plus x squared plus y squared plus z squared equals r squared. That's the equation of a sphere with a center at the origin. So let's try one. Okay, finding the equation of a sphere. Find the standard equation of the sphere with center at 2, 4, and 3, and then radius 3. So does this sphere intersect the xy plane? Is a good question to ask. The equation of the sphere with center h, k, and j equals 2, 4, and 3, and a radius equals 3 is what are we going to do with it? So here's our standard equation of a sphere. We're going to plug in some values here, 2, 4, and 3. This is our x, y, and z here. And we're going to substitute in 3 here for radius. So we substitute in values. And then from the graph, now we can graph the thing, get a general idea of what's going on here. 2, 4, and 0. What the heck's that? We have our 0 here, 2, 4, 3. Our radius is 3. So we can draw a circle that way and then draw a circle around this way as well. And then we're going to say, does this sphere intersect the XY plane? Well, you can see that the center of the sphere lies what? Center of this sphere lies 3 units above the XY plane. So it lies 3 units above the XY plane. Because the sphere has a radius of 3, you can conclude, remember 2, 4, and 3. 3 will be our elevation here. It will be our Z element here for this point. You can conclude that it does intersect the XY plane at the point 2, 4, and then 0. Here's your intersection here of the XY plane. Here's your XY plane down here. So it does intersect it there. Okay, let's try one. Find the standard form of the equation of the sphere with the given characteristics. So we have a center here at 0, 4, and 3. And then a radius 4. So find the standard form of the equation. Since this is yours down here, do that one on your own. We're going to do this one now. So for a center at 0, 4, 3, h is 0, k is 4, and then j would be 3, and then we have a radius of 4. So now we can plug in our values here into the standard form of the equation of a sphere, and then we simplify it to this down here, x squared plus y minus 4 quantity squared plus z minus 3 quantity squared equals 16. So that would be our equation for this sphere here. Finding the center and radius of a sphere. Find the center and radius of the sphere given by, and then we have this equation here. So to obtain the standard equation of this sphere, complete the square as follows. So here's our original expression here. So we're going to group our like terms together. We have x squared minus 2x blank. That's going to be our completion there of the square. And then we have our y squared plus 4y. So y squared plus 4y plus blank. We don't know yet how that's going to complete out. And then we have z squared minus 6z. So z squared minus 6z plus blank. We don't know what that's going to be. And let's see, we move this one over here. This is kind of a stray value over here. So we got to complete these squares here first before we can actually get to this. This is what it's going to look like. So next. So when we complete these out, 1/2 of 2 is squared is 1, 1/2 of 4 squared is 4, then 1/2 of -3 squared is 9, and then we add those over to this other side as well. And then what we have now is this. This is our expression here. So we have square root of 6 squared, and to complete that out, so the center of the sphere would be the negative of -1, the negative of +2, then the negative of -3 would be 3, so it'd be 1. So it'd be 1, -2, and then +3. There'd be our center. And then our radius would be radical 6, which is this here. And then we could draw a circle like that. So that would be what it would look like. So let's try one. Find the center and radius of this sphere here. So what do? What's our first step, students? First step here is to group like terms together, and then complete our squares just like we did in the previous. So x squared, then 2y, y squared. Let's see, was it x squared and -4x? I'm sorry, and y squared and 2y. and then z squared, and then negative 6z, and move this thing over there. And then once we complete our squares over here, remember to add that to the other side as well. And then now you got perfect squares over here, and then you combine your constants over here to get positive 4. And then so now your center is the negative of negative 2, the negative of 1, and then the negative of negative 3. There's your center, 2, negative 1, 3, and then we have a radius, square root of 4 would be 2. So there is your center and radius of this sphere here. Note in example 5 that the points satisfying the equation of the sphere are surface points, not interior points. In general, the collection of points satisfying an equation involving x, y, and z is called a surface in space. Finding the intersection of a surface with one of the 3 coordinate planes or with a plane parallel to one of the 3 coordinate planes helps one visualize the surface. Such an intersection is called a trace of the surface. For example, the xy trace of a surface consists of all points that are common to both the surface and the xy. So what would that look like? Finding a trace of a surface, sketch the xy trace of the sphere given by, this is our equation here of our sphere. So to find the xy trace of this surface, find the xy trace of the sphere given here, use the fact that every point in the xy plane has a z coordinate of 0. By substituting z equals 0 into the original equation, so we put 0 up here, the resulting equation will represent the intersection of the surface with the xy plane. So here's our original, and then if we plug in a 0 here, substitute 0 for z, we get this thing here, x minus 3 quantity squared plus y minus 2 quantity squared plus 16 now equals 25. So we get that far. So we simplify out when we plug in our value here. And then once we have that, we can write our original equation. And then now substitute 0 for z. We're going to do this again just so you make sure you have it. Substitute 0 for z. And then we're going to simplify back again. So we have this expression again. And then what we do here is we move our 16 over there, and then we're left with this. Subtract 16 from each side. So now what do we have here? Basically, that's an equation of a circle, right? So x minus 3 quantity squared plus y minus 2 quantity squared equals 3 squared. We have an equation of a circle. From this form, you can see that the xy trace is a circle with a radius of 3, which would be right here is where it would be. So, and then that's what this equation represents, is a circle. And then from our sphere here, it is a surface trace, and it's an xy trace taken from this sphere is what that is. Okay, let's try one. Sketch the graph of the equation, then sketch the specified trace. So we have x minus 1 quantity squared plus y squared plus z squared equals 36. And we're looking for an xz trace now is what we're looking for. So we're trying to find an xz trace. We're going to make our y equals 0. And we plug in a 0 up here, we end up with x minus 1 quantity squared plus z squared equals 36. So this would be the circle here that we can trace here. And then it would be actually this line, this circumference here would be our trace for from this sphere here, an xz trace from this sphere. And that would be how you would find it. Sketch the graph of the equation and then sketch the specified trace. Here would be your trace for that. And as your 10.1 Part 2 Pre-Calculus Math classwork lesson, email me at animatedpowerpointmathvideo@aol.com for materials or questions. Thank you very much.